lymphatic components in different models, which is how we test you even now. But then at some point we imported this model from Germany, and it took its own sweet time, and when it came it was so heavy that we had to always have it in this prostrate position, not prostate, remember, prostrate position. So with all of that extra comment, you're looking at a model that helps us study some aspects of lymphatic system. In this model, needless to say, anything which is seen in blue here is indicating systemic vein. Right? Systemic vein, you don't see arteries, there's no need for the arteries in this model. And then what you see as white structures here indicate lymph vessels of some sort. Also, as we go through it, we'll identify the structures. So the venous system is shown here because ultimately all lymph gets poured back into the blood and into the venous blood to become whole again before blood returns to heart. So for that reason you see the veins over in this model. So again, I would say under lymphatic system, if you follow the list on the very first page, you have lymph vessels of different kinds. The smallest lymph vessels obviously are called lymph capillaries. And in the last test, you saw example of lymph capillaries in the small intestine, in the villi, which have specific name, and they are called lacteal. Other places, yes, they are lymph capillaries. So remember to bring in lacteal again as part of endocrine system. So lymph vessels are one part of lymphatic system. What these vessels carry would be clear fluid, which is called the lymph. Also, in addition to those tiny lymph vessels, lymph capillaries, lymph vessels keep on merging like veins merge or venules merge and then become veins. These keep on merging and become larger with their specific names. I would say the largest lymph vessels are called ducts. The smallest are called lymph capillaries. In between, they are different sizes, and just before they become ducts, lymph vessels are called lymphatic trunks. So we have lymphatic ducts, we have lymphatic trunks, we have lymph vessels of different sizes, going to the smallest ones as lymph capillaries. And I'm sure from your study of Module 1, you know lymph always travels from organs out. It is produced in the organs and comes out and travels toward the heart. So lymph vessels never need an arrow on them. Very much like veins never need an arrow on them, because venous blood always is traveling away from organs toward the heart, except for hepatic portal vein. And that's true for veins as well, always traveling out of the organs toward the heart. So any of these lymph vessels that you see here, including this one, is going like this. The lymph is traveling like this. As lymph travels through the lymph vessels, in between, it passes through masses of lymphatic tissue. Looks like I'm teaching the lecture topic here, but couldn't hurt. It passes through masses of lymphatic tissue called lymph nodes. And lymph nodes are distributed here, there, everywhere in the body. Not only that, so they also come in different sizes. So there is everything very, I would say, they provide a lot of variety. Everything about it is different. They come in different locations, they come in different sizes, they come in different shapes, etc. But the common thing about all lymph nodes is they receive the lymph into them, clean the lymph up, filter the lymph, and then lymph exits. So they lie along the path of lymph circulation, lymph travel, lymph journey. So any of these lymph vessels here then is entering the lymph node when they are on this side of the lymph vessel. The one which are on the other side, for example, this one, this is the incoming one and that's the outgoing one. And I'm sure you know Incoming would always be called afferent, and outgoing is always called efferent. This is not a new terminology. You've used it for nerves in anatomy 1, afferent nerve, efferent nerve, incoming into the brain and outgoing. So keep that word in mind. We'll use it again under urinary system. So incoming vessel. As you look at this, yes, this would be an afferent lymph vessel, whereas this would be efferent. The question is, how do we know with regard to the lymph node? So it's always with regard to a certain lymph node, because what enters this one in this sequence, let's number them 1, 2, and 3. What enters number 2 is leaving number 1. So for number 1 lymph node, this vessel would be efferent vessel. That becomes afferent for number 2. Efferent of number 2 becomes afferent for number 3 because lymph is flowing in this direction. So the terminology of afferent, efferent is always with regard to a certain lymph node. But given the model, what do? You identify these as lymphatic vessels. And then specifically, if you're asked to identify them as efferent, afferent, then you always do it with regard to a lymph node. That's part 1. I did say lymph vessels become larger, become trunk, and the trunks get their name from their location, mediastinal trunk and cervical trunk and so on. Finally, all of the lymph from all over the body is sent into one of the 2 ducts. In other words, when you follow the list on the very first page of the lymphatic exercise, you have only 2 names there for the ducts, right? You see those names. What do we see? Names of the ducts.
The collecting ducts. Oh, the thoracic duct.
The thoracic duct and right lymphatic duct are the ultimate 2 ducts. Very much like ultimate 2 veins would be superior vena cava, inferior vena cava, right? So ultimately 2 ducts, final ducts that have all of the lymph from all over the body, every part of the body, lymph ultimately ends up in either thoracic duct or right lymphatic duct.
I have a question.
Yes.
How do you know that this lymph vessel is always going to go like this way into the lymph node or that way? Like, is there a certain direction?
Right. It's always going to come upward toward the heart.
Okay.
Very much like in this case, we always know blood is going to go this way and not the opposite way. And another thing to keep in mind for lymph vessels when you compare them with venous circulation is lymph vessels inside them also have the valves to prevent the backward flow.
Okay.
So lymph will always travel forward. Okay, good question. So 2 lymphatic ducts, thoracic and right lymphatic duct. Of the 2, right lymphatic duct is much smaller. Why so? Because it has lymph only from upper right parts of the body. The area of drainage or area of collection for right lymphatic duct is right arm, right side of the neck, right side of the head. That's all. Rest of the lymph from all over here, see how it is, all over this, all of that comes into thoracic duct. So thoracic duct then is the largest lymph vessel that you would want to know about. Largest lymph vessel is the thoracic duct because it has lymph from every part of the body except right upper part, which goes into the right lymphatic duct. So what you see here, all of the lymph that is in these lymph vessels is ultimately going into thoracic duct. The question is, where is the thoracic duct? One would say at least in the thorax, right? And that's what you see. It forms right here at the beginning of the thorax, right here. This is that thoracic duct I'm talking about, beautifully shown in the model. And at the beginning of thoracic duct, that means at the point of entry, at the point of formation of thoracic duct, there is a little bag-like structure, a sac-like structure. If you remember anything from cytology and structure of the Golgi apparatus, you would know that Golgi apparatus is made up of a number of cisterna. I don't know how many of you remember that. A number of sacs. So remember the word cisterna means a sac. This is like a sac. It's called cisterna chyli. So thoracic duct starts with cisterna chyli. And note that as cisterna chyli comes into being, a number of thoracic ducts from different direction from the abdominal area are entering into it. This part is that cisterna chyli. Rest of it is then thoracic duct proper. All of that lymph from here, from pelvic cavity, abdominal cavity has arrived into cisterna chyli. And cisterna chyli, I should say. And then thoracic duct continues to receive more and more lymph. Ultimately, thoracic duct, or both of the ducts I should say, become part of the venous circulation. We have a model here that shows some of the veins, and I need to check if you still remember what these veins are. Let's look at this part. What vein is this? Talking about this one. This one.
Right carotid.
So it's superior vena cava?
Superior vena cava. The heart would be here. This is superior vena cava. How does superior vena cava form? Merger of what? Two veins. Can't exit anatomy too.
Subclavian and jugular.
Subclavian and internal jugular merge to make something. What do they make?
Carotid? No,
Brachial
that's
There's no
cephalic.
brachiocephalic vein. On the right and left. Internal jugular subclavian merge